Okay, so this is our last section of the similarity unit, and we're learning about an angle bisector theorem. So basically, if we are given that a ray will bisect an angle, so this is our ray that's bisecting angle G, splitting into two congruent parts, then it's going to divide the opposite sides proportionally. So again, we're going to be setting up two different ratios, talking about the relationship between those two, and creating a proportion out of it. So in this case, we're always thinking about, yes, this is our ray, right, that's bisecting the angle. So we're thinking about the left-hand side, thinking about the right-hand side. So with that, we're thinking about side, base, right, side over base, and setting it equal to the side over the base. And in this case, we're just clarifying that by GEO, GMMO. But we're going to put some numbers to it in this next example problem. So again, this is our ray that's bisecting that angle. The two numbers on the left-hand side, right, this is our side measure, this is our base measure, 12 over x. Then we're setting it equal to the right-hand side. Side is 5, base is 3. Cool. And we have numbers attached to both. So they're, pretty straightforward. We have 12 times 3 to get 36, and x times 5 to get 5x. When we divide both sides by 5 on both sides, we will get 7.2. That's our final answer. Okay, I want you to try this next one, and I am going to do it with you. I'm just not going to talk. So give it a shot. Yeah, good luck. So you should have gotten 3.75, setting up the left-hand side and then the right-hand side. We are going to step it up a gear. So again, we're thinking about that ray that's bisecting the angle and making sure that we have the correct expression for those missing side measures or those missing bases. A lot of times we're going to represent a part of the base, like we were doing very, very shortly on the side splitter. So here, we're going to start with creating our ratio, right? Side over base. So our side is the 21. The part of the base, right, to the blue, is x. We have measures for both of those. So we're doing 21 over x. Okay, now going to the right-hand side. We have our side, which is the 24 over the base. Oh, we don't have a specific number to it, right? We don't have one number right here. 35 is talking about the entire measure. X is talking about a part. So we need to represent that as an algebraic expression. So we're thinking whole minus the part of what we're given. And that's going to be our base measure on the right-hand side. So again, setting up that ratio, side over base. We're going to get some big numbers here, guys, just a warning. Now let's go ahead and cross multiply. So we have x times 24 to get 24x. And then we're setting it equal to 21 times 35 minus x. Then it's a matter of distributing that 21 to both terms. So we get 24x equals 735 minus 21x. We add the 21 on both sides, and we will get 45x equals 735. When we divide both sides by 45, we will get x is equal to 16.3. Final answer. Okay, so that's probably as hard as it's going to get because we have to make that as an expression. So let's give this next one a shot as well. So we have our side over base. And in this case, we have numbers for both the side and the base. Now let's try that right-hand side. Chances are we might have to do some expression work. We have our side, which is 18, over the base. Now, is there a number right directly under it? Talking about the measure of that segment. Answer is no. So we need to make that segment the whole minus the part. That's the measure of our base on a green side. So let's do our side over our base ratio. Okay, same thing goes over here. We're cross multiplying, right? 18 times x. 14 times 20 minus x. Go ahead and distribute. 18x equals 280 minus 14x. We add the 14 on both sides and we get 32x equals 280. When we divide both sides by 32, we will get x is equal to 8.75. And really it should be x, not BC. And that's our final answer. We can also give this next one a shot. I'm not going to talk you through it. I want you to try it on your own. But surely you could follow along with what I'm writing. So in doing this problem, you should get 19.5 as that final answer for the measure of x. And then for the last problem, again, we're still doing angle bisector problems. We want to find first the measure of AC and CD. So I'm going to pick, right, one of those things to solve for. I'm going to label AC, and the diagram is x. Okay, so then I'm just going back to my angle bisector theorem, right? Side over base equals side over base. So side, and we have our base measure of x. So 4 over x. Then on that right hand side, right, we're doing side 6 over base, right? But we don't know the measure of CD. Let's represent that as the whole minus the part, like we've been doing. And then we can continue on with that ratio. Side over base. Do some cross multiplying, right? So we have 6 times x, 6x. Then we'll multiply the 4 by the 10 minus x. Do some distribution. 4 times 10 is 40. 4 times negative x, negative 4x. Add that 4 on both sides. We get 10x is equal to 40. Divide both sides by 10. We get x is equal to 4, which just happens to be, right, the measure of AC. AC is x. X we just found out was 4. Okay, we now want to figure out what CD is. CD has this measure, right, algebraic expression of 10 minus x. Well, we know that x is 4, so if we do 10 minus 4, we get 6. So if AC is 4 and CD is 6, does that make 10? Yeah, we've done the problem correctly. Here we go.